Before we can start writing proofs for congruent triangles, we need to talk about what it means to have two congruent triangles. So if I'm looking at these two triangles here, I have triangle ABC, and I have triangle DEF. If these two triangles are congruent to each other, then corresponding parts of those triangles are going to be congruent to each other. So first thing I'll think about is the sides. So in this case, I would say that A would have to be congruent to D, because when I look at my original triangle setup, A and D are in the same position in that triangle. So A and D have to be congruent. In the same way, B and E are the second letter in that triangle. So B would have to be congruent to E. And now we have to distinguish between the different angles. A and D are congruent to each other, but they're not necessarily congruent to B and E. So we have to give that 2 ticks, and we'll give A and D 1 tick. Finally, our third angle, C and F, would have to be congruent to each other. So we'll do 3 ticks for that, and 3 ticks for F. So these are the corresponding angles, the angles that match, the angles that are the same from one triangle to the next. Okay, we can also talk about the same thing with the sides. So order matters again. AB and DE should be congruent. So I'm going to put 1 tick mark for AB, and I'm going to put 1 tick mark for DE. BC would match with EF. So BC will now get 2 tick marks, and EF will get the same 2 tick marks, because now I know that BC and EF will be the same. They will be congruent. So finally, the third pair of sides that are going to be congruent are going to be AC and then DF. And they'll get 3 tick marks so that we know that those two are going to be congruent to each other. Okay, so we've labeled our shapes, and that's wonderful. But when we start talking about proofs, we need to figure out ways that I know triangles will be congruent to each other from some given information. So when we talk about triangle congruence, there's 4 basic ways that I can prove that two triangles will be congruent to each other so that all the parts of the triangles will be congruent to each other. So the first way we're going to talk about is side, side, side. And we abbreviate that as S, S, S. Okay, side, side, side. So if I were to label that in this triangle over here, I would need to have 3 pairs of sides that were corresponding and were congruent. So 3 pairs of sides that were the same and in the same spots in the triangles. So I could label that side, and I would say those were congruent. These 2 pairs of sides would be congruent. And the final pair of sides would be congruent. So now I have 3 pairs of congruent sides that correspond in these 2 triangles, so I know that these 2 triangles are going to be congruent. All right. Another way that we can talk about congruence would be side angle side. And we abbreviate side angle side as SAS. So in this one, order matters. We need a pair of congruent sides, then a pair of congruent angles, and then another pair of congruent sides. So that angle needs to be trapped in between those 2 pairs of sides. So let's say this is my first pair of congruent sides. My angles would be trapped in that corner, and then my second pair of congruent sides would be here. So you can see that we have a side, then an angle, and a side here, and we have a side, an angle, and a side here. So whenever we're looking to prove by side angle side, you need to have a pair of sides with an angle trapped in between those 2 sides. So next up, we can do angle side angle. So angle side angle is going to be abbreviated as ASA. The same way that we had an angle trapped between 2 sides before, Now we're going to have a side trapped between two congruent angles. So I have an angle here and an angle here. Then I need to have a side. So I have a side and a side that are congruent. Then I need another pair of congruent angles. So we're going to label this with 2 ticks as opposed to 1 because I'm not sure if they're equal to the other ones, but I sure know that they're equal to each other. So again, looking at the problem here, I have an angle, a side, and an angle. Okay, that's the important part, that the order matters. You have an angle, a side, and an angle. That side is trapped between those 2 angles. All right, and the last one we're going to have here is called angle, angle, side. An angle, angle, side is abbreviated as AAS. So angle, angle, side, we would need 2 adjacent angles. And adjacent means that they're next to each other in order in the triangle. So I would say I have an angle, and then I have another angle. So they're adjacent. I started in the top and I went down to the bottom right. They are in order in that triangle. If I'm bouncing around the triangle, there's one right next to the other. Then I have the side. So it's angle, angle, and then I have a pair of sides that are congruent. All right, so again, the order matters. You have an angle, and then the side. It's really important when we're trying to talk about triangle congruence and parts of triangles that are congruent that I'm always looking back at these 4 congruence theorems to say whether or not triangles are congruent. These are the only 4 ways that I'm going to be able to tell whether 2 triangles are going to be congruent to one another. So if I can prove any one of these 4 things is true, then I can prove that the 2 triangles are congruent, and I can prove that any parts of those triangles are going to be congruent. The last thing that we see a lot is something called the reflexive property. And that happens when you have 2 triangles that share a side together. So these 2 triangles obviously share this side. So if they share the same exact side, then I know that that side has to be equal to itself. Right? That's the reflexive property. And again, that happens when a side or angle is equal to itself. So I know that that line where I just put that tick mark is going to be equal to itself. So let's take a look at this proof. I'm given these triangles. They're labeled. And I want to prove that triangle ABC is congruent to triangle DCB. So if you look to the right, they give me that information. Even if they hadn't written it down, it's labeled in the picture because side AB has 2 tick marks and side CD has 2 tick marks. So I know that they're congruent to one another. So the first thing I'm going to write in my statement is AB, with a line over it because that's side AB, is congruent. It's a little equal sign with a squiggle. Is congruent to side CD. I can also say that angle C and angle B are congruent. Now I can't just say C and B because there's another little bit of an angle here in this section that's part of C. So I need to talk about angle BCD and angle CBA. So we're going to write that also. The reason for both of those things is just that they're given. So that was something that they just gave to me. I know that that's true, so I can write that down right away. If it wasn't labeled in the picture, then you go ahead and label that here. Makes your life a lot easier to have a visual of what's happening. Okay, so now we need to think about what we have and what we still need. So I like to try to think about it in terms of ways to prove triangles are congruent. So the only ways that I know to prove that triangles are congruent are going to be side, angle, side, 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 angle, side, angle, or angle, angle, side. They're my only possible ways to prove that triangles are congruent. So then I think back, okay, well, what do I have right now? Well, I have a side, pair of congruent sides, and I have a pair of congruent angles. So right away I know that side, side, side isn't going to be the theorem for me because it's going to take more work for me. Okay, so the rest are still possibilities. So now let's take a look back at the figure. We talked earlier about reflexive, and when triangles share a side, like this side BC, that it's got to be equal to itself. So what I can do then is say that side BC is congruent to side BC, and the reasoning will be the reflexive property. I know it's equal to itself, so I can mark that. So from here we have enough information then to use one of our congruence postulates. I'm looking that I have now a side, a pair of angles, and another side that's going to be the same in both of these triangles. So now we can say we have side angle side congruence. So to write that in our statement and reason, we are really trying to say that triangle ABC is congruent to triangle DCB. And our reasoning would be side angle side congruence. So now I can start talking about sides and angles that are congruent in both of those triangles. If I know that two things are in the same position in congruent triangles, I know that they're going to be congruent to one another. So in this case, let's take a peek. I know angle A is in the same position as angle D. So I know that those two are going to be congruent to one another. So I'm going to add a line here to this proof. We've already proven what we wanted, but I'm going to say a couple extra things here. So I know now that angle A is going to be congruent to angle D. And the reason for that is a really long phrase called corresponding parts of congruent triangles are congruent. So we are going to abbreviate that as CPCTC. So if in the future you're looking at two sets of triangles and they give you some information and they ask you to prove something other than the triangles are congruent, so let's say you want to prove that two angles or two sides are congruent, you're always going to first have to prove that the triangles are equal to each other, and then match up the sides or angles to prove that they are also congruent by CPCTC.